So now we're going to do some equations of circles. Like lines, circles have equations too. So you might remember that you graphed a line, I don't know, put it on like XY axis, and it was like a Y equals X line. And earlier in other math courses, you graphed parabolas, and they were like Y equals X squared. So now if we want to graph a circle, what do you think it is? Well, that's what we're going to find out. Let's check it out. So first of all, let's graph a circle. We want to plot as many points as possible that are 5 units from the origin. And it says we should be able to get more than 4. Well, let's see. So there's the origin. I should get more than 4 points, huh? So if I go to the right 5, well, there's 1 point. Up 5 is 2 points. Over 5 is 3 points. And down 5 is 4 points. So now I should get another point. Well, just like eyeballing some distances, it looks like maybe this point here is about 5 units away. And a good way to check it is to maybe think about the Pythagorean theorem. So if I do that Pythagorean theorem where this side is 3 and that side is 4, if I do a Pythagorean theorem, 3 squared is 9, 4 squared is 16, that's going to give me 25, and the square root of 25 is 5. Yes. So that point is 5 units away. Cool. So let me think about doing combinations of 3 and 4 as well. And let me erase some of those points there. So I said that point 3 and 4 was there. Well, what if I went 3 to the left and 4 up? That's another point. What if I go 3 to the left and 4 down? And what if I go 3 to the right and 4 down? So there's a bunch of points. Now, I know I went like a 3 to the right and 4. What if I go 4 to the right and 3 up? I mean, that's still going to be a right triangle. 4, 3, that's still going to be 5. So if I go combinations of 4 and 3, 4 to the left and right, 3 up and down, I'm going to get a bunch of points. So look at all those points. They make a circle. Now, those are not the only points that are on the grid or that are on our graph. I'm going to put like this point here. That point P is on my graph. Now, I don't know its coordinates. I'm going to call it x comma y. I know you're saying, well, why are we doing that? Well, here's why we're doing that. Because I want to write a Pythagorean theorem equation now that says that that point P is 5 units from the origin. So I'm just going to recreate that picture real quick. So here's my point P. Call it x comma y. Here's the origin. It's 0, 0, right? And I say that that is on the circle, so it's 5 units from the origin. Well, here's my Pythagorean theorem. There's my triangle. I don't know how far I went over. Call it x. Don't know how high I went up. Call it y. So now if I do a Pythagorean theorem, I'm going to get x squared, which is my a value, x squared plus y squared equals 5 squared, or x squared plus y squared equals 25. Well, guess what? If I put this point P anywhere else on the circle, if I put it, let's see, can I move it around? Yeah. If I put it there, or if I put it down here, or if I put it down there, I'm still going to be able to do the same Pythagorean equation. So guess what? This thing here is the equation of my circle. It's the equation of the circle with the center at 0, 0. The center is at the origin. Can you tell that the radius is the square root of 25 or 5? Because of the Pythagorean theorem, that's squaring at the end. So this kind of motivates me a little bit. Now maybe I can write the equation of other circles. So for example, if the radius was 7, I can do x squared plus y squared equals 7 squared. Or we could write x squared plus y squared equals 49. I think you see it. Yep. So we'll do also x squared plus y squared equals 10 squared. So we get x squared plus y squared is 100. Oh, we love writing equations of circles. And I think you can probably jump ahead a little bit and just go x squared plus y squared equals 9. Because remember, 3 squared equals 9. Ooh, look at this last one. The radius in this one is r. So what if we call it x squared plus y squared equals r squared? That's kind of like the formula for the equation of a circle, is that we take the radius and then we square it. Cool. So they all have a different radii, but do you notice that they all are centered at the origin? What happens if it's not? Well, let's play with it and see what happens. Again, let's do another Pythagorean theorem equation. The radius this time is 6, and the center is at 3, -2. So maybe here's like the point 3, -2, somewhere down here. That's my center. And I got a circle that goes around it, something like that, right? And my point P is out there. And I know that this distance is 6. So let's do a Pythagorean theorem, or maybe even a distance formula. You want to do the distance formula? That makes it even better. Check this out. Let's do the distance formula. Because the distance formula is the same thing as the Pythagorean theorem. But I got these points, so it's going to make it a little easier. So let's see, I'm going to do the square root. Let's move that square root over a little bit, because we're going to need a big square root. We're going to subtract the x's. So let's do x minus 3 and square it. And then let's do y minus -2. Is it okay if I do y plus 2? Remember, y minus -2 is equal to y plus 2. So that's my distance. But I know my distance. I know my distance is 6. Well, that's a really ugly equation. So why don't we do this? Why don't we square both sides of the equation? Squaring the right side just gives me 36, which is okay, because didn't we before square the radius anyway? So that's our radius squared. And look what we got on the left side now. The square of x minus 3, the square of y plus 2. Look at that equation. Can you see where the center is? Can you see where the radius is? Can you see that the center, let's write the word for center first. If the center's at 3, -2, can you see how the 3 is in there and how the -2 is in there? And can you see how the radius is 6? So let's see if we can write some equations now. Here we go. Now we want to write the equation of a circle given this center and radius. All right, so I know I got to put like x minus the x value in. So I got to do x subtract -2. Remember that from before? How that's going to become x plus 2. And then we get a y minus 4. And then we're going to put our radius, 3 squared, which is 9, right? Great. Let's do the same with the next one. The center's at 0, 6. I think you're getting the idea. Let's do x minus 0 squared. Hey, isn't x minus 0, though, just x? So x squared plus, and we'll do y minus 6 squared equals 81. And check out this last one. This is our like formula, if you will. Again, we're going to call this like h comma k. You might remember this from like the point slope form of a line. So we'll do x minus h, where h is the x value. Y minus k, where k is the y value of the center. We'll do those terms squared. We'll add them, and it equals the radius squared. So this is the formula that I'd like you to remember for the equation of a circle, because this one doesn't have to be at the origin. The center's at any other point, h comma k, and the radius is r. Beautiful, beautiful. All right, let's keep playing a little bit. Ooh, can we sketch a graph of a circle? Oh, that's going to be fun. Let's check out the graph of a circle. So I'm going to graph the point. Let's see, I need a center, right? So can we work backwards from here? and say that the center is at the point 2, -3? Yeah, because remember, it's x subtract the x value of the center. So the x value of the center is 2. And it's y subtract the y value of the center. So the y value of the center is -3. And then the radius equals the square root of 25, which is 5. And I can graph a bunch of points with this one. Here's my 2, -3. And let's go to the right 5. 1, 2, 3, 4, 5. Let's go up 5. Let's go left 5. Let's go down 5. Is that 5? I'm going to move my board down a wee bit. There we go. Let's go down 5. And check it out. Because of the Pythagorean theorem, I can also do a bunch of like right 3 and up 4. And right 4 and up 3 to that point there. Not that one in the middle. And I can do a bunch of other like 3s and 4s. Let's see, 1, 2, 3, 1, 2, 3, 4. And that point, 4, 3. And down here, 4, 3, and 3, 4 that way. And again, from the center, go to the right 3 and down 4. Go to the right 4, down 3. I got a bunch of points I can graph. And the neat thing is, the more points that you graph, the better you could be. So that's a beautiful circle. Oh, I love it. Love it. Now, if the radius was something different, like let's do a circle up here real quick. Like here's the center of the circle, and let's say like the radius is 2. Okay, so I can go up 2, over 2, down 2, and left 2. I can't find any, I mean, there are other points that are in here, but can't do like a Pythagorean theorem really well for that. So I just graph those 4 points and kind of do the best circle I can. That's okay. But if you can do like a Pythagorean theorem of 5, oh my goodness, it's beautiful. All right, one last thing. Can we find the equation of this circle here? So if I'm looking for the equation of this circle, I know it's going to look something like this. It's going to be like x minus something squared plus y minus something else squared equals whatever my radius is squared. So let's see if I can fill those numbers in. So here's my center point. It looks like the center, let's see, the origin is about here. So it looks like the center's at -4, 2. So I'm going to put -4 there, and I'm going to put 2 there. There's my center, -4, 2. And now let's see what the radius is. It looks like I go up 1, 2, 3, 4, 5. So my radius is 5. So the equation of my circle then is going to be x plus 4, that value squared, that's sum squared, plus the square of y minus 2 equals 25. So think about all the wonderful things you can do. You can write the equation of a circle if you're given a circle. You can sketch the graph of a circle, and you could probably identify the center and radius of that. And if I give you a center and radius, you can write the equation of that circle. Oh, so many good things you can do with circles.